Okay, here's some help for number 10. It's like number 9, except the difference is that Q1 is negative and Q2 is positive. So if you imagine you put a positive charge somewhere between them, if this charge was positive, this negative charge and this positive charge would attract. So there'd be a force going this way on Q3 due to Q1. But this is positive and that's positive. So there'd be a force on Q3 going to the left also due to Q2. And there's no way those two forces will ever cancel each other. So it turns out that you cannot have a solution between Q1 and Q2 because their signs are different. So we need to figure out a better way to do this. So let's start over and let's think about, will the point where there can be a net force of 0 be to the left or to the right? Well, in your problem, Q2 is bigger than Q1. So if you put the charge over here on the right, there is no place where the force due to Q2 will be the same size as the force due to Q1 because Q2 is a bigger charge and it'll always be closer to Q2. So the force due to Q2 will always be bigger. So it turns out that the solution is going to be putting the third charge over here somewhere. So we're going to call this Q, and I'm going to call the distance from here to here x. So let's call this distance x. And then what you're going to do is you're going to do the same thing you did in problem number 2. You're going to say the magnitude of the force on 3, so we're going to call this Q3, due to 1, that's the force on 3 due to 1, and since imagine this being positive and that being negative, that's going to be to the right. There's going to be a force to the right. That has to equal, the size of it has to equal the force on 3 due to 2. Okay, and so the force on 3 due to 2. So the force on 3 due to 1 will be K Q3 Q1 over x squared. And that's going to have to equal the force on 3 due to 2, which is going to be K Q3 Q2 divided by x plus d squared, because it's over to the left here. And then you can solve that equation for x. And then, because this is a number line and Q1 is at 0, when you find x, the position of Q3 is actually going to be a negative value. But you need to solve for x first for this problem, and then make it negative.